right. I think it should. All right, there it is.
All right. Thank you very much, everybody. Let's call this meeting to order. The May meeting of the Warren Astronomical Society. I'm Diane Hall, your president for 2021. Thank you very much for joining us tonight. We'll kick things off by running through the officers' reports. Just want to remind you all that we have tentative plans to have the picnic in person in August of this year. It will be subject to changes. We reevaluate things for public safety. We are planning to have a virtual banquet again. And as our astronomy at the beach representatives remind us, that may be a hybrid. The team has not fully decided there. But right now, your board has been planning on a in-person picnic, virtual banquet, and subject to change. Stay tuned. I'd also like to give a shout out to our editor of the WASP and all the contributors, because the magazine has just been absolutely fabulous. I thought this issue was particularly a standout, so I'd like to thank all the wonderful people who have been contributing on a regular basis to the Warren Astronomical Society paper to make it amazing. So thank you all. And with that, I'd like to pass things to First Vice President Dr. Dale Parton for his report.
Thank you, Diane. At our next meeting on May the 20th, Gillen Brown will be our speaker. He is working on his doctorate at the University of Michigan. His topic will be the origin of the elements. Then a month from now, on June 7th, Doug Bach will be the main speaker. He will be showing us a video taken by WASP Club members during the eclipse of the sun back in 1979. It's been digitized, all the video, and he'll be narrating it for us. It's called Chasing the Eclipse. And there will also be a short presentation by Kevin McLaughlin. So I'd like to put out a plea for speakers. We have openings in the schedule as early as in July, and some later in the year as well. So if you have something brewing, something you could contribute, please let me know. Okay, Diane, back to you.
Thank you, Dale. Our second vice president, Riyadh, has been having some technical difficulties tonight, so I will be reading his report for us. Observatory report from May 2021. Stargate Observatory of the Dobbs Shed, along with all equipment, are in good condition as of April 30th, 2021. There will be no open house on site in May, as the observatory will remain closed until further notice. Virtual observing and discussion may be possible from the Northern Cross Observatory, depending on the weather, and if Doug Bach, who owns the NCO, is available to host it. So we will let y'all know as the date approaches what form it'll take and send out the WebEx link to y'all. The date is set for 8 p.m. May 22nd. So it may be live streaming, it may be discussion. Stay tuned. And with that, I'd like to hand things over to Secretary Mark Kedzier.
Thank you, President. Diane, the minutes of the WASP for the April meetings are in that fine publication that Diane mentioned, and that's all I have to report. Thank you.
Didn't you have a shout out to a certain library program, Mark?
I stand corrected. It has been, for some of you that don't know, if you're familiar with the Library Telescope program, that is something that was started back in 2008 by the New Hampshire Astronomical Society, based on the premise: if you go to a library and check out a book, why can't you check out a telescope? Well, it's grown all over the country with astronomy clubs, and with the blessing of the Warren Astronomical Board officers, I was able to connect with the Grosse Pointe Public Libraries. And in June of 2015, we launched the program, and we had 8 telescopes go into circulation for the patrons of the Grosse Pointe Library. I represent the Warren Astronomical Society and keeping the scopes maintained in tip-top shape, and was doing a monthly presentation, helping people learn how to use the telescopes, and also showing them kind of like some like our in the sky program for them, just to get them familiar with astronomy. And well, the COVID pandemic put a kibosh on doing those presentations, but we'll be starting up visual presentations again. And also, I was just in the library, and they have been checking out the telescopes for their patrons, and so that's a positive thing. So I got them all in working order, except for 3. I have 3 more to go. So the program's going on strong. It'll be 6 years this June that the program has been going. So we're very proud of that, and I look forward to that. And hopefully I'll be able to report some more to you as we get this thing launched again.
Excellent. Thank you very much. And Adrian at Treasury.
All right, hello everyone. So Treasury's been holding steady. We're sitting at around 22,000 in the main WAS account, 3,200 for the account for GLAC, and around 1,100 we have a PayPal account that we also use, and it's grown to around $1,100, $1,100 if you prefer. So reimbursements and expenditures and things can happen. Thank you to those of you who have renewed your membership or have are joining us for the first time. Your names, I don't recall them all, but your names are in the WASP. I submitted that as a part of my report, the new memberships that I got over the month of April. And I'll continue doing those new memberships for all future months and putting those submitting those for the WASPs as well. So that is basically it. I was gonna lie and say that I used all the funds to buy some new equipment, but I did not. I used my own money. Your WASP money is safe and will continue to be under my watch. Any questions? Email treasurer@warrenastro.org. I will be visiting the P.O. box if you have sent in your renewal or new membership checks if you're here with us, and I will be processing them. I can process them online through my phone. So once I get the new checks, I will be processing them without even having to go into the bank. So that is it for my report.
All right. Thank you, Adrian. And I'd like to thank, on behalf of the entire board, just the sheer number of people who have renewed their membership in the last 6 months. Really great to have the level of participation we have from y'all, even though everything has been virtual. So thank you very much for your commitment to the club. And with that,
I'll
yes,
jump in because I mentioned we're around 173, 174 new memberships.
yeah,
And
that's
still
really
growing.
good, gang. That's really impressive. And with that, I'd like to pass things to outreach.
All right. I'd like to say we had a fairly light outreach month, but I got 2 pages worth of stuff in the WASP here. Adrian has been doing these sessions with Explore Scientific, and they've gotten him this really cool badge, so that's in there. I ran a Kerbal Space Program session on Yuri's night. It wasn't attended by very many people. We had a WASP member, but my young nephew connected up, and I reconnected with an old college buddy that I haven't spoken with in like 10 years. So that was pretty cool. And my nephew was like, yeah, every time I launched a rocket. So hopefully that had the desired effect. A write-up by Mark Kedzier of what he just reported is in the outreach section. The Great Lakes Association of Astronomy Club took a break last month, so there's nothing to report there. I have the date for the next meeting, and remember, if you want to attend these meetings and see what's going on for planning astronomy at the beach, you are more than welcome. The Zoom link is there. Other than that, I'd just like to remind everyone out there that we have a large group of people that do outreach events, and a lot of them we're comfortable doing those online. So if you have like schools, I've done stuff for schools, and I know Ken Burton and other people have done online presentations. So we are available if you're interested in that. Email outreach@warrenastro.org, and we will get you someone to speak. That's it for outreach.
Thank you, Bob, and Dale at Publications.
Thank you, Diane. Well, cat's out of the bag. The WASP is up. And a big thanks to all who helped me get it out online by May 1st. It's also my pleasure to add an additional article from a Macomb College professor, Dr. Christopher Zinn, thanks to the efforts of Dale Parton. And hopefully more will follow. That's my report.
Thank you again, and be sure to check out the WASP this month, gang. It's a beauty. Okay, subgroups. I don't think I see Solar Marty. Feel free to throw a link to the sun in the chat, and we will progress to. A reminder that double star groups will reconvene when the observing resumes at Stargate. Do we have astrophotography on the line? Well, in addition
If
to the yes.
not here, I can do a real quick report, and it's that those of us that have been out, there's been comet imaging. We had the open house where we discussed astrophotography recently, and I'm still getting images of the zodiacal light. I have an image that, if I can find it, I'll show it later during the break, showing the faint zodiacal light seen at Lake Hudson State Park, so which is a Bortle 4 sky. So there's been a lot of activity in astrophotography, especially with outreach beginning to have a couple different venues. Libraries are looking for to do with space. So, and as Bob has mentioned, so we're busy. Folks are firing up their observatories, and it's galaxy season, so that's what we're aiming at. A lot of the galaxies of Leo, a lot of clusters. So and I here. So Doug, I'll turn the floor over to you.
So just for astrophotography, I do a live broadcast whenever the sky is clear in the evenings, and I have the observatory open, and I'm usually running 2 or 3 objects for the night. You're more than welcome to join my WebEx, and in addition to the open house that I host, you're more than welcome to join me during those sessions as well. You'll just have to keep track of my Facebook page for when I go live under Northern Cross Observatory.
Thank you very much, Doug. Yes, astrophotography has been going gangbusters, especially during the virtual open house nights. So if you have been contemplating the hobby, this is a fantastic time to dive in, and a lot of people are willing to give you a hand in this club. So thank you, gang. And history group, I know your latest adventures are detailed in the WASP. I think you're muted.
Okay. So we found 2 more issues that haven't been scanned in before. That's November and December of 1973. As from the now the name's blown on my head.
Dave Harrington's collection.
Dave Harrington's collection. That's right. Yeah. Thank you, Doug. anyways, I got a boatload of issues from them, and 2 of them were never before seen in our digitized collection. So I digitized and posted them on our website. So anyone who wants to check them out, they're there.
Excellent. Thank you, Dale. And finally,
Okay.
Astronomical League. The window for joining the Astronomical League is steadily approaching. So if you are interested in renewing or interested in joining, check out the dues pricing schedule on our webpage and send a check or a PayPal to Adrian. Okay. Do we have some observing reports? I know we do.
Well, since you asked,
Indeed.
let's see here. There's been a comet coming north. It was first seen out in the southern hemisphere, but it's been heading north and west over the last several months. And let me see if I can pull this up here. Oh, no, here we go. I want to run a short video of Comet 2020 R4 Atlas. It's only 30 seconds, so it'll take me longer to launch it than it to actually play it. Here we go. We have to get past the commercial first. Okay, here we go. Let me launch it over here. So this comet is about 11th magnitude. And I ran all night on this object, and I tracked on the comet itself right here.
I don't see it, Doug.
Oh, geez. Okay, hang on a second. Sorry. I forgot to share. Thank you. There we go.
That's better.
All right, so here we go. So I took about 3.5 hours worth of data, or 3 hours and 45 minutes worth of data, made a time lapse of it. And you can see that the sky is moving and the comet's staying relatively stationary because I'm tracking on the comet itself.
Nice.
It's about 11th magnitude. We had a couple of satellites flash through during the time period. This is 656 frames of 15 seconds each using my 10-inch RC. So that's my observing report.
All right. Thank you, Doug. Next observing report. I know you've got some. Ah, David, I see your hand up. Go for
Yeah,
it.
thank you. Can you hear me okay?
Yes.
Good. Anyway, I wanted to say, I think I tried to do a visual observation of Comet Atlas around the same time that you were photographing it. Visually, it is about as close to non-existent as you can get and still be there. Literally, it reminds me of Peltier, to hunt a speck of moving haze. That's all it looked like to me visually. Last night, I went out to our own club's dark site with a friend of mine, and we spent a couple of hours doing some wonderful observing. And tonight, in fact, just a short while from now, I will be going to another dark site. And that is why you don't see Minerva, my telescope, right next to me. It is all ready to go, observing tonight. So next time, maybe. Anyway, my quote for this meeting comes from Gene Shoemaker. Right after our discovery of Shoemaker Levy 9 and the impacts, we were being interviewed for a National Geographic program, and he did a very memorable quotation that I had the honor of reading earlier this afternoon to Carolyn Shoemaker when I had my weekly phone call with her. And this is what Gene says: "No, I'm not going to make it to the moon. Just at the critical time when I should have been standing at the head of the line to go to the moon, my adrenal cortex stopped functioning. And I knew that would knock me out of the running medically. When you have that idea in your head for 15 years, it just doesn't go away. I was immensely pleased and proud of Jack Schmidt. But of course, I was wistful too. I couldn't help the feeling that there, but for that failed adrenal gland, go I. For a long time after, I used to have dreams. Thought I got there, got to the moon, was there doing geology. I had to go do other things. We all know that the other things that Gene had to do was he got his wife Carolyn and later on me to do an asteroid and comet search project at Palomar Observatory, and that led to a lot of comet discoveries, including the discovery of Comet Shoemaker Levy 9. I'm kind of glad things worked out the way they did for him, and I'm glad that life has kind of worked out that way, and I'm so glad to be here with this meeting tonight. And with that, back to you. Thank you.
Thank you, David. Yeah, no, amazing career and a great story that definitely deserves more exposure.
Yeah.
All right, I think I see Adrian's hand up.
I'm coming to you live from an iPhone, and I still think I can share. I'm only going to share one. The observation that I've been talking about with here we are with the zodiacal light still barely visible. And I will, let's see if we can do this. Here is, okay, that's the image that
Ah,
this is, it's a little, I call it, it's a little prettier, but it's not as easy to see the light, the faint light moving along the ecliptic in this one. This was something that I had posted. I will pick the other image, which should show it a little bit better. And that should be it. Hopefully I wasn't, okay. That's the full image. Hopefully it shows up. You should be able to see that faint light going through where Gemini is, and then you can see some of the bright stars, Canis Minor. That's the winter circle. When I first imaged the zodiacal light at Port Crescent, it was the winter circle that it was cutting through, and that's still the winter circle. So even though it's let's see, I think March 30th was the solstice, and we're already in May, but in some places the zodiacal light is still barely visible if you get there at the right time. I think it just about disappeared around, well, when Gemini set, I think around midnight, it all but disappeared as we moved away from the plane of the solar system. So it's still out there, and it's in its final, I'll call it its final throes. If you can get to somewhere at least Bortle 4 after sunset, give it about an hour, and you should see this faint strip of light angled along the ecliptic. If you see that, you are looking at what's left of the zodiacal light. And as we've learned recently from the Juno mission, hopefully I get this right, it turns out the zodiacal light is now believed to be dust coming off of Mars. That the dust follows the orbit of Mars, so it's believed to be dust that is actually escaping the planet, and is so now it's its own entity running around the ecliptic. We thought it was comet dust or something else, but now we've corrected it to all because of Mars. So that is my report, and I am open to corrections on the zodiacal light, but I do believe that's what we know it to be now.
So is Ingenuity stirring up extra dust for us?
I'm
don't
sure
think so.
Probably not.
Well, if Ingenuity gets caught in one of those dust storms, I think that will be the end of Ingenuity.
No, Ingenuity has a nuclear power plant. It's not solar like Spirit and Opportunity were. Oh, Ingenuity, the helicopter. Yeah, helicopter is going to be dead. Yeah.
It might hit out of the sky by one of those dust storms if it hits. So
Yeah.
I'm sure they're
No,
scanning.
it's solar. It would be dead. Yeah.
So,
Very good. Okay. Let's see. It's 7:58. I think it's time. We can take one more observing report, and otherwise we're going to in the news. Any takers? Any hands up?
Well, I did take a galaxy back here on the 1st of May.
Okay. We love galaxies. Oh, that's pretty. M63. Nice.
Yeah. Yeah, it has a lot of structure in it. Okay, that's all I had.
Wonderful. Okay, let's turn things over to Outreach Chair Bob Tremblay, who's doing tonight's In the News in the Sky. You ready, Bob? One moment. Bob's taking over.
Mute. Testing, testing.
We hear ya.
All right, so let's see. Share this guy. Alrighty. There. I've got too many windows open. Okay. In the news, when I started writing this presentation a couple days ago, I went and I looked for a previous presentation that I could copy and use as a format, and I saw this. I'm like, wow, that's exactly what I want to talk about. This is the same picture I used for my intro in my February in the news, and it's appropriate, so that's pretty funny. So, first thing we're talking about is the sad news of the passing of Michael Collins. I'm actually reading his book right now, and so Diane has a very nice write-up in the WASP, dedication to him. Michael Collins was an Apollo 11 pilot, and Kennedy Space Center did a dedication to him on April 30th, the visitor complex. So very, very sad news. Crew Dragon returns in the middle of the night. At about 3 a.m. on May 2nd, the Crew Dragon returned, and they did some really cool IR footage of the parachutes opening up, and that was very cool. So this was up in space for 168 days. The mission marks the end of the first crew rotation mission to the International Space Station of the Crew Dragon spacecraft. So that's really cool. Perseverance rover. One of the experiments on it, a technology demonstration, was the MOXIE thing. It's an in situ resource utilization device which converts carbon dioxide into oxygen, and the technology could isolate and store oxygen on Mars to help power rockets and provide oxygen, breathable oxygen for astronauts. The chemical reaction is I looked at that and was like, how on earth do you convert CO2 into oxygen? Well, this is the process. It creates carbon monoxide as a waste gas and vents that out. There's talk about sending a much larger version with a much larger power plant that could do like 5 pounds of oxygen per day, and that would be pretty cool. So experiment worked, and so yay, that's pretty cool. Ingenuity. Data received by the Mars Ingenuity helicopter on Thursday of last shows the helicopter did not execute its planned fourth flight as scheduled. An issue was identified earlier the month and showed a 15% chance for each time the helicopter attempted to fly, it would encounter what's called a watchdog timer event and not transition into flight mode. And that's what happened on this day. So they tried again. And on the 30th, the flight was a success. And you'll notice I'm seeing all these things on Twitter. Twitter is just fantastic for getting news about events from NASA. So here is a picture from the rover looking at the helicopter. Can you spot the helicopter? Ingenuity successfully completed its fourth flight on April 30th. The helicopter took flight and climbed to an altitude of 16 feet, 5 meters, and then flew south about 436 feet, 133 meters, and then back. Total round trip, 872 feet for a 117-second flight. This image was taken from the rover. So there's a close-up of it. So the helicopter in the air. So next steps, what's going on with next steps? Well, the Ingenuity rover craft will now shift focus from proving that flight is possible on Mars to demonstrating flight operations that future aerial craft could utilize. The fifth flight would send Ingenuity on a one-way mission landing at the new site. If Ingenuity remains healthy after those flights, the next phase can begin. With short drives expected for Perseverance in the near term, Ingenuity may execute flights that land near the rover's current position or its next anticipated parking spot. The helicopter can use these opportunities to perform aerial observations of rover science targets, potential rover routes, and inaccessible features while also capturing stereo images for digital elevation maps. The lessons learned from these efforts will provide significant benefit to future mission planners. These scouting flights are a bonus and not a requirement for Perseverance to complete its science mission. But this was a question asked by my grumpy 84-year-old father-in-law when I was describing this helicopter. What have we learned by putting a helicopter on Mars? So, well, we've learned that we can fly in a low-pressure atmosphere. This can be used by aerial reconnaissance where rovers can't go. The materials research that went into developing these blades, something is going to come of that. And something that was pointed out to me is that this kind of technology could be used for high altitude recon and rescue here on the Earth. And the one thing that I haven't seen a whole lot of people mention is the inspiration. How do you put a value, or how do you quantify the act of inspiring the youth to go into science and engineering? So I know this happened during the Apollo era. A lot of scientists and engineers, very famous ones, were inspired by the Apollo era. And I see kids today inspired by the helicopter, which is very, very cool. So one of the things I reported about in the WASP was while I was working this week, I was watching this IAA Planetary Defense Conference. I was only able to watch the first 2 days. The last 3 days I was just really busy with work, but it would be easy to do an hour-long presentation on just the first 2 days. There is so much more going on than I even thought about when it comes to planetary defense. And they were talking about what they had during this conference was a hypothetical asteroid had been discovered with a 5% chance of impacting the Earth. And during the course of the conference, that number increased to 100%. And they showed how they calculate where it's going to impact. And there's a whole lot of questions surrounding, who makes the announcement? And this I wrote in the WASP because the information about a impactor is going to be available online through social media before a lot of people that generally would be announcing it have even got a chance to look at it. So that'll be interesting. So again, I wrote a lengthy thing on the WASP. Read that. It's pretty interesting. So in astronomy news, astronomers are watching a gas giant grow before their very eyes. They've managed to directly image an exoplanet PDS-70b, making it one of only about 15 that have been directly imaged so far, and the youngest of those imaged by Hubble's. Using a novel post-processing technique, scientists were able to block out the light from the star and leave only the light emitted from the planet to be analyzed. In doing so, they decreased the exoplanet's maximum orbit around the star that can be viewed by Hubble by a factor of 5. So expect to see more discovered. PDS-70b is a relatively young planet, about 5 million years old, and has already grown to about the size of approximately 5 Jupiters. Over the course of the future, it'll only be collecting about 1/100th of the mass of Jupiter more. So I'll be talking more about exoplanets in the sky, which is next in the sky. So here's our inner solar system. Parker Solar Probe is whipped around the sun for another apogee, getting closer and closer. The OSIRIS-REx mission is still in proximity with Bennu. It'll be leaving on the 10th. And 67P is coming back in. I wonder if that's going to be visible when it gets near Earth orbit in a couple months. So middle solar system, there's you got 67P going up by Jupiter, and there's Jupiter and Saturn still in the morning sky. And there's the outer solar system. Lots of stuff out there. So this week, the moon is third quarter today, appearing in the southeastern pre-dawn sky. Tomorrow it'll be a waning crescent, heading towards the new moon on the 11th. The moon returns to the western sky at sunset later next week. So there's Jupiter and Saturn. They appear in the southeastern pre-dawn sky. The moon will be in conjunction with Jupiter tomorrow, and on the 5th the moon will be right near Jupiter. The Eta Aquariids meteor shower happens tonight, but it'll not be very visible in northern latitudes, as the radiant does not clear the horizon until about 2 or 3 a.m. So viewing is best in the southern tropics. But look where the moon is. That couldn't be in a worse position for this meteor shower. So don't expect to see a whole lot this year. So Mars appears above the constellation Orion in the western sky after sunset. Orion has nearly set at dusk. Summer is coming. And I was wondering where Venus and Mercury were in stellariums, and I turned the atmosphere off, and there they are, right before sunset, but they're way lost in the glare of the sun. But they're there at sunset. So, and at midnight, Adrian was looking for something to look at. Hercules and Lyra, hosting a couple of very interesting objects to look at, are in the sky, rising at about midnight in the eastern sky. So when it comes to exoplanets, we have 4383 confirmed, with a total of 4248 candidates from Kepler, K2, and TESS yet to be confirmed. So there's a lot of exoplanets in the sky. So that's my In the Sky report for tonight, and thank you, everyone.
Thank you, Bob. And if you're
Stop
interested in doing
sharing.
In the News in the Sky, let me or Dr. Dale Parton know, particularly if there's a news story that you just have to talk about prior to a meeting. With that, I will turn things over to Dr. Dale Parton to introduce our first speaker of the night.
Before we go to a snack after the speaker, I got a little something to add about Michael Collins, if you don't mind. I'd like
Okay.
to. All right.
All right.
After the speaker.
Take it away, Dr. Dale.
Okay, thank you, Diane. I've sort of watched Jenny nervously wondering when she's going to fit into this program tonight. She will be our first speaker tonight. She's a third-year graduate student in astronomy and astrophysics at the University of Michigan. She studies protoplanetary disks using a combination of radio observations and computer models. When she's not doing geeky stuff like that, she enjoys cooking, hiking, and creative writing, and various other activities. Her subject tonight will be the temperature profile of a protoplanetary disk. Jenny, it's all yours.
Great. Thank you so much for that introduction. I'll go ahead and try and share my screen. Bear with me. This is the first time I've used WebEx, so I'm gonna try, let's see.
All right, we can see your desktop there.
Okay, do you see the keynote by chance?
Nope. Now we
Nope.
do.
Oh, you do? Okay, let me try and hit play. How's that?
We're up and rolling. Thank you.
Yay! Great. Awesome. And if the slides don't seem to be progressing or anything, feel free to interrupt me at any time. So yeah, hi everyone. Thank you so much for inviting me. I'm really excited to give a talk about my research. which is determining the temperature profile within protoplanetary disks. So I'll talk a little bit about what protoplanetary disks are, but you've already seen one tonight. PDS-70 is a protoplanetary disk with an exoplanet in it, so it was really cool to see that. Yeah, so generally I'm interested in both star and planet formation and how that all works together. And stars form in these beautiful regions. I'm sure most of you recognize this. This is the pillars of creation, these giant clouds of dust and gas. And if we zoom into a region like this, you'll see a lot of things going on. All the redness is a lot of gas, and then these really bright regions are really young stars that have just recently formed. But I actually want to focus on these clumps of dust and gas because this is kind of stage or step 0 in the star formation and planet formation process. So with one of these clouds of dust and gas, it will eventually infall in on itself based only on gravity, and it will start to form a star in the very center. Since space isn't perfect, it's not going to fall directly inwards. There's going to be some sort of rotation within this cloud, and because of that, a disk actually forms in the very center around the star. And so this is the start of a protoplanetary disk. Eventually, that cloud of dust and gas kind of dissipates, either falls onto the disk or the star or goes away. And so you're left with a really thin envelope, but a big protoplanetary disk in the very center, with a star in the very, very center. And then eventually that protoplanetary disk can form planets. So if we want to learn how our Earth formed or how Jupiter formed, or how we can form systems of planets that are so diverse like our own solar system, we first need to understand protoplanetary disks and their environments and how they can possibly form planets. So in particular, I'm most interested in determining the mass and the temperature of a protoplanetary disk. Each of these two characteristics can tell us more about the planet formation potential of a disk. So mass, pretty simply, it just tells you how much stuff there is in the disk. So it can tell you how many planets this disk could possibly form. Could it form 5 Jupiters? Could it form 20? Could it form 100 Earths? Like stuff like that. It's a pretty basic characteristic that is essential if we want to understand like how many protoplanetary disks have the ability to even form planets. And then there's temperature. Temperature feeds into a lot of different things we want to understand about planet formation. In particular, I want to focus on chemistry. So in certain regions, certain molecules will either be in the gas phase or frozen onto grains, and that is dictated by the temperature. And when a certain molecule is in the gas phase, it can go through very specific reactions that are gas phase reactions. Or while it's cold and frozen onto grains, it might be too cold to move at all, so there won't be a lot of chemistry happening. Or if there are a lot of the same chemicals, it can do grain phase chemistry. So mass and temperature are very important characteristics to know about a disk, but also they feed into each other. Because if you look at a disk, and this is an example of a disk, where the blue is the gas part and then the reddish background is the dust part. But if you look at a disk and it looks like bright or dim, that could mean that it's either high or low mass, or it could mean that it is hot or cold. So a hot disk can be really bright because there's like a lot of energy that is energizing a lot of the gas and the molecules, so it's going to look really bright. Or a really massive disk can look really bright because there's a lot of gas there. So they're it's really hard to disentangle the two. And so because of that, I really want to get a good understanding of the temperature within the disk, because it feeds into our understanding of chemistry and where chemistry happens within the disk. But also we need to know the temperature in order to determine the mass of the disk. So a little bit more about how protoplanetary disks are kind of made up. This is our disk, and I'm going to take like a little slice of the protoplanetary disk to zoom in on the different parts of the disk. In the very center, we have this dusty midplane. So there's dust in there. And when I say dust, I mean like 1 millimeter sized particles would be like a really big dust grain. So there's anywhere from like 1 millimeter to like micron sized dust. So it's a lot smaller typically than like the dust in our house. And this is where planets actively form. And yeah, so those are the planets. And then there's this flared disk gas atmosphere. So it goes way above and way beyond the dusty part of the disk. And so it has a lot of gas. The most abundant gas is H2, just 2 hydrogen atoms together. But there's also CO, there's HCN, there are a ton of molecules that we find within the gas of the disk. And this is actually what I observe mostly using radio telescopes, is the gas part of the disk. So this is my little cartoon of how I observe protoplanetary disks. In particular, I look at carbon monoxide, so C and O together. You've heard of carbon monoxide because you have carbon monoxide detectors, hopefully. It's very toxic to humans, but it's a very, very common molecule within protoplanetary disks and in outer space in general, and it's a really common reactant to form other life-forming molecules. And I can use CO to determine the temperature. And I actually use 3 different flavors of CO to do so. So the first one is just normal CO. So it has a carbon and an oxygen, and the carbon has 12, well, it has 6 protons, 6 neutrons, so 6 nucleons, and then the oxygen has 8 protons and 8 neutrons. And that is kind of the normal version, because if we look at the periodic table, you can see that every carbon atom has 3 protons, every oxygen atom has 8 protons, and so that's just normal CO. But there are other versions of CO. There's 13C16O. So we have a normal oxygen atom, but we have an extra neutron within the carbon. So it's like chemically identical to 12C16O, but there's a little bit of an extra neutron in there, so it's a little bit heavier. And then there's also 12C18O that I use. And so this oxygen atom has 2 extra neutrons within it. And the nice thing about these is, as I mentioned, they're chemically identical. So they'll be distributed throughout the disk pretty much identically. And they'll go through the same chemical reactions and all that. They're practically the same, but they emit at slightly different frequencies because they're slightly different weights and they have slightly different things in their nucleus. So we can utilize that to actually probe different regions within the disk. So this is another cartoon version of a protoplanetary disk, and I'm observing 12C16O, so the basic vanilla carbon monoxide. Since there's so much of it within a disk, we're actually only going to be sensitive to a certain height within the disk. So we're only going to be sensitive to the regions closest to us because it's what we call optically thick. A kind of extreme example would be like my wall, or the walls in your house are optically thick because I'm only getting information from one side of the wall. I can't get any information about how thick it is. And that's like CO, the 12C16O. It's really, really optically thick, so we're only getting information, including only temperature information, from a certain region within the disk. If we go to a slightly less abundant version of CO, so 13CO, we're actually going to be probing a slightly different region, a little bit deeper within the disk. And we're still getting temperature information, but from a different region. And same story, but with the C18O, we're getting even deeper into the disk. So we can kind of combine all 3 of these different versions of carbon monoxide to get temperature information throughout the 2D extent of the disk, both radially and vertically. And so these are real observations of a protoplanetary disk called TW Hydra. It's the nearest protoplanetary disk to us, in the different kind of flavors of CO. And the idea is, with these observations, I then want to go to my computer and make a model of a protoplanetary disk. And the idea is, if I can make a model that reproduces all of these observations, if I can find a way to create a temperature profile, a disk, makeup setup, like distribution of gas and dust, and I can reproduce these observations, that means my disk model on my computer is representative of what's actually out there in the disk. And so I did that. That one click was like a year of work. But yeah, I went ahead and was able to reproduce all of these observations of these 3 versions of CO, as well as a few others that I'm not picturing. And so with that, I was able to determine the temperature structure of a protoplanetary disk. Very generally, I now know where it's going to be very, very hot, where it's going to be pretty cold, especially in the planet forming region, and like very, very cold, way, way far away from the star. So yeah, in summary, I use both observations and computer simulations in order to take the temperature of protoplanetary disks, which can feed into our understanding of how planets form in general. And this is just a figure from one of my more recent papers to show you like what that gas temperature like information looks like. We can plot the gas temperature in units of Kelvin. So these are actually really, really, really cold. You might know that 0 Kelvin is like the coldest it can possibly be out there in the universe. I don't know off the top of my head what it is in Fahrenheit, but it's like negative numbers. Very, very, very cold. But anyway, so we can get the gas temperature, the dust temperature, and then we can compare the gas and dust temperatures that we find. And we find that throughout the vast majority of the disk and where the planets are forming and where most of the mass of the planet is, the temperatures of both the gas and the dust are coupled, so they're the same temperature. We find this really interesting temperature inversion region where the dust temperature becomes a bit hotter, and then way, way high up in the atmosphere, the gas temperature just explodes and it gets really, really hot. And yeah, I also showed the CO abundance, so where the CO is within the disk. So that was my quick summary of my research. Thank you for inviting me. I'm super happy to take any questions.
Awesome. Thank you. Yes, let's have some questions. Gregory Frederick has a question. Unmute yourself, Gregory, and let's have it.
Okay, hi Jenny. My background being a mechanical engineer, I've used different types of software for modeling, but automotive related things like crash and vibration analysis and temperature effects on the vehicle. Are you using a CFD software, an FEA software, a multi-body dynamics software, or what? What kind of software do you use?
Yeah, great question. None of those terms really stood out to me. So I use Python mostly is the
Oh, I
coding
know
language I
Python.
use. Okay, great. And so the code I use, I actually inherited from another scientist within the research group I'm in, and it
Yeah.
uses Fortran as like kind of the meat of the code. It has like a Python wrapper, so I can like I can like set up different models using Python, but like Fortran is like the main coding language that is like generating the chemical equations and temperature calculations. And it's a thermochemical code. So there aren't any like it's not like an n-body simulation. There aren't like things moving really. We just care about the temperature and the chemistry. So yeah, I
So
hope that
it's
answered your question.
yeah, it's like a thermal gradient kind of analysis or something. You're just looking at temperature profiles then?
Yeah, that sounds right. Yeah, the temperature profile and how that is affected by the radiation from the star and from the ISM. So we like evolve it over a period of time to see how the temperature changes over time. Yeah.
Yeah, I've done temperature analysis, but thank you.
Yeah, thanks for asking.
Awesome. Got some more questions? Oh, Bob Tremblay asked, why is the temp in the upper part of the disk so high?
Yes, good question. Okay, so the star is like here at 0, and the star gives out radiation, of course, in like all directions, up, down, mostly sideways towards the disk. And so where the gas temperature just like goes like to crazy high numbers, that's where there's not much dust anymore. And so the dust does a pretty good job of blocking a lot of heat, and that's why it's really cold over here. And then once you take away that dust, like there's still gas out there and there's nothing stopping it from becoming really hot. Yeah, good question.
All right, more questions. Oh, Bob Tremblay has another one. How big are those protoplanetary disks compared to our solar system? And that's the last one from Bob before somebody else gets a word in.
Fair enough. Yeah, so let's see. So there's the dust part of the disk and then there's the gas part. The gas part is really, really big. So I think out to like Neptune or the Oort cloud, that's like a few tens of AU astronomical units. But this disk, the gas part extends out to like 600 AU. So like, 6 times the size of our solar system. The dust part is more on par with the size of our solar system and goes out to around like Oort cloud. Lengths, but of course there's like a ton of different types of protoplanetary disks. The one I'm showing in this figure is one of the biggest that we know of. There are some that are much smaller. Of course there's a wide diversity out there, but usually the gas extends way far beyond what our solar system is.
I have a question. How far away can you get good data on these disks? Are they all within our galaxy, or close parts of our galaxy? Like, how far away can they be to still get usable data?
Yeah, good question. So the TW Hydra disk that I talked about earlier, the nearest one, is around 60 parsecs away. So I want to say that's 120-ish light years. So that's the nearest, so that's ideal. But then I'd say the farthest away, they're definitely within our galaxy. They can maybe go out to like hundreds of parsecs away. So I'd say, every astronomer has a different definition of what's like near and close. But I'd say definitely within our own galaxy, and I'd say like it has to be pretty close to us. If it's on the opposite side of our galaxy, there's really no way of detecting it, especially if we have to like look through all the dust and the stuff in the center of our galaxy. It has to be like on our side in our quadrant pretty much. But yeah, like this research I don't think would have been able to be done even 10 years ago based on the telescopes that we had. We've really only been able to like spatially resolve disks, even the really close disks, recently using the fancy new telescopes like ALMA in Chile, which is made of like individual radio dishes that work together to like act as a really big telescope. And that's been like a really recent innovation that's been able to allow us to do this kind of research. Yeah.
Thank you.
Yeah.
All right, we got two more questions in the chat. Russell Boyce asks, have you heard of the meter size problem? The lack of theory about how planets form. That's news to me. Jenny, is that?
Yeah, I have heard of this, and I haven't like studied this problem very closely, so I may not be the best person to answer this. But yeah, the meter size problem is basically like, how do we form planets? We need like these little pebble things to form into Jupiter-sized objects. Like, how do we do that? Do they just like stick together like that? And it seems like really small pebbles do a good job of like sticking together pretty well. But once you get up to a meter in size, two like meter-sized objects crash into each other, they don't stick. Like theoretically, they would just break apart. So how do you ever get past that barrier? And I think one part of that solution that only recently has really been like out there and is starting to be tested is that there's has to be some sort of like dynamical friction that will slow things down. Whether that be the gas that the dust is living in, somehow that can like slow it down a little bit so it goes to a slow enough velocity where it will kind of stick together. Actually, I think that's the only solution I've heard of so far, but it is a really interesting problem right now and something that we really need to solve if we ever want to begin to understand how any planet formed.
Okay, thank you. Yeah,
Yeah,
that's been a big puzzle. Thank you.
yeah, of course.
Fabulous. And we've got one last question to slip in. Back to Gregory Frederick. What have you got for us, Gregory?
I'm just curious, the James Webb Telescope, how would that impact your future research?
Yes,
Since
absolutely.
it's infrared detecting, right? Looking through
True.
dust.
Exactly. Yeah. So good point. So this is all like radio data that I've been working with, but JWST is going to be super powerful for protoplanetary disk research and planet formation research. So the infrared is going to be, slightly warmer and probe warmer regions than the radio. So it's going to be really sensitive to the inner disk. And when I say the inner disk, I mean like where the Earth is forming and where most planets form actually. So within like 25 AU-ish, which encompasses Jupiter, all the terrestrial planets. And that's a region that's really, really hard to probe with any radio telescope just because it's such a tiny scale. But JWST is going to be really sensitive to, infrared lines. Like water, we haven't really had a good job of detecting water directly within protoplanetary disks, and that's kind of weird. We expect there to be a lot of water, but the sticky and kind of problem with water is that it evaporates or it freezes onto grains actually really at kind of low-ish temperatures. So that's been hard to see in radio wavelengths, but we think we will be able to see it with JWST. So that'll be a big problem that a lot of people will try and address. Yeah, so JWST is going to be great also for exoplanets too, and exoplanet atmospheres and characterizing how we get molecules and how they evolve over time through the star formation to protoplanetary disk to exoplanet stages is going to be really interesting. Awesome
Thanks.
question. It's very exciting. Yeah.
All right, and I guess I lied. There's one more quickie question. I think that's a yes or no. Do you plan on scheduling time on the JWST?
I would love to schedule time. I applied in the first round and I did not get time. I was very competitive, but I'm certainly going to try again.
All right. Well, best of luck with that. Thank you so
Thank
much,
you.
Jenny.
Yeah, thanks for having me.
And yeah, our pleasure. And it's the bottom of the hour, so it is time for a half-hour break. And we have something new that we're trying tonight. It's breakout rooms. So instead of everybody either turn off their mic or everybody trying to talk, we're going to have there's a new member channel that we can have people come in if they want to get some FaceTime with our veterans or officers. There's an astrophotography channel for the astro imaging people to go full bore geek for half an hour. And what's the other one, Jonathan?
Diane, I have that thing about Collins I wanted to mention.
Yeah. All right, let's go now since we're recording and the breakout rooms haven't opened yet. Ken has some additional words on my favorite astronaut, so take it away, Ken.
All right. Well, I just wanted to mention to you that I saw the Apollo 11 landing when I was stationed at Fort Sill, Oklahoma. And in 1986, Linda, my daughter Jenny, and I went on a cruise to see Halley's Comet in the Caribbean. And on that trip were several astronomy personalities, including Michael Collins. I found him a little distant, but he warmed up to my wife immediately when he learned that she was a soap opera fan and one of her favorite actresses was Michael Collins' daughter.
Yes.
He gave a great talk. But on that trip, just to say something else, that's where I first encountered Fred Espenak. That's where I first met him. And he's one of my best friends now, of course. And then on the trip was also a fellow by the name of Leon Jeriff, who was the science editor for Time magazine, who was instrumental in getting the Discover magazine started. He was the founding editor for 4 years, and then he went back to Time. He wrote many stories about it. There was a fellow by the name of Fred Hess on the journey, who ran the Hayden Planetarium for several years, and also a fellow by the name of George Tamian, who's a brilliant scientist. As a matter of fact, Michael Collins had said on that trip, when somebody asked him an astronomy question, he says to the people, he says, "You better ask George. He's the guy who'll know all the answers." And a great sense of humor, Michael Collins. It was a terrific experience. And of course, Jenny got to see it when she was 10 years old. So she has a chance to see it when it returns in 2062. But I just wanted to mention to that, Collins was fabulous. He was just the nicest man you could imagine. I just wanted to mention that.
Yeah, he was, I wish I could have met him because he's a genuinely classy guy.
Classy guy is right.
All right.
Thanks.
So how do we open up these breakout rooms? Here we go, breakout sessions. All right, so we've got astrophotography, new people, and casual chat. All right, that's the other one is casual chat. So I guess y'all message me to let me know who wants to go in astrophotography, new people, or casual chat, and I'll pop you in there for the remainder of our break.
How do you get there?
I have to assign you to that, it looks like.
Okay.
So where do you want to go, Ken?
Casual chat, be fine.
Okay.
What time are we all coming back together?
9 o'clock. Like an old-fashioned Cranbrook meeting. All right. Okay, who else wants to go in who wants to go in astrophotography?
I'll go in astrophotography. Send
No
me the.
No kidding.
Okay.
Where else am I supposed to? I can go to
Big
casual chat and
surprise.
start talking astro. I can go into casual chat and go start talking astro there. I'm
Whatever
sure
you
that'll
want to
defeat
do.
the purpose.
Makes no difference. And anywhere you are, Adrian, I'd be glad to be.
All right, let's see if this works. Let's see if y'all disappear.
All right. Send me breakout session started. You've been assigned to the astrophotography breakout session. Join.
All right. Who wants to go in new people?
I'd like to go new people. If there are any new people coming to new people, I'd be glad to chat with new people like I do at the meetings.
I would love that to happen. Let me see if I can assign people. Oh, hey, how's this work?
Diane, do you have to be using the software, or can you do that with someone joining through the browser?
I don't know.
Because I'm on the browser. It's Cheryl.
Okay, yes, I recognize your voice. Let's see.